Hello guys, my name is Spiros Katsios and today we're going to see how we can implement authorization in the application level of an app that uses clean architecture. Let's go to our solution. As you can see, the domain project is actually empty. So let's go to our infrastructure one. I have an app DB context that inherits from the identity DB context, as well as an identity service that has, among other stuff, a sign-in user async method that checks the credentials of a user, and if they are correct, it generates a token, and finally it returns back an auth result. The code is available on GitHub, so I won't go in much details about all the methods, the results, the mappers, etc. in our solution. Instead, I will focus on the important for our purpose parts. Having said that, let's go to our token service. And in here you can see that in the token we pass the ID of the user as well as all the claims they have. Again, how we actually create the token and set up the identity is outside of the scope of the video. You can check all that in the source code. Let's move to our application project. In here I have a sign-in command that uses the identity service and returns that auth result. I also have some queries. I have a user query that returns a hello user string, a supervisor query that returns a hello supervisor, a manager query that returns a hello manager, and an admin query that returns only for admin's eyes. Now let's go to our API project. In the program .cs file I add my dependencies as well authentication and authorization, and I call the seedData class which set up some roles and user from the app settings. That's the seedData. We have three methods: setup roles, create admins async, and create managers async. And if I go to the app settings, in here I have my roles, my admin users, and my manager user. Let's move to our controllers. We have an identity controller that returns an auth response which contains the token, and a message controller that is decorated with the Authorize attribute. So we need to be signed in to use its endpoints unless some of them specifically say otherwise, by being decorated with the allow anonymous attribute. As you can see, the get message for users, which returns the result of the user query, can be called by anyone who signed in, but the get message for supervisor can be called only for a user that has a role of a supervisor. The get message for manager only by a user that has a role of manager, and the get message for admin only for a user that has a role of admin. Now let's go back to our queries and let's go to our admin query. We get a hint from the name that that's something that only an admin could call, but again we couldn't be sure, and that's because we introduced that constraint in our API project. So what we're going to do is to handle our authorization in the application level. We can do the same for the authentication as well, but for the sake of time we won't. We will focus only on the authorization. Now before we start, let's add one more piece of logic. Let's say that in our application everyone with a higher role can call everything that the one with a lower role can call. So let's go back to our message controller and remove everything that has to do with authorize. Okay. Now we need to put somewhere our roles instead of having some string here and there. We could add a class with some constant strings, but since we have that hierarchy in our roles, it will be more handy to use an enum. So let's go in our application and create a folder identity. And in here, let's create our role enum. Okay, so that needs to be an enum, and now let's add our roles. We have the admin. Let's specifically say that is 1. We'll do the same for the supervisor, and finally it adds 2, and finally for our manager. Actually the manager maybe is it's a higher role than a supervisor. I know that roles don't actually make sense, but it's just for the example. Okay. Now, since our I requests are the ones that we want to authorize, let's create an attribute so we can decorate them. Okay, in here in our identity, I'll create an authorize attribute. Okay, that needs to inherit from the attribute, and we will have a property. It will be from the enum role. It will be the enum role type, I'm sorry. Now we can also have a policy in here, but for the sake of the time we will only focus in the role-based authorization. Okay, I think we are good. Let's also create an empty constructor. Excellent. Okay, now in our endpoints we create our requests and we send them through the mediator pipeline so they can eventually go to their respective handlers. We want to interrupt that flow and process a request with an authorized attribute only if the user is authorized. So we need to create a pipeline behavior. In our application we will call a folder called behaviors, and in here we'll write the authorization behavior. Now let's go and start with the boilerplate stuff. So that's an int request the response, and that inherits from the I pipeline behavior of the request the response, and we need to add the constraint that the request implements the I request of the response. Okay, now let's go and implement our missing members. Alright, that will actually be an asynchronous task. Now let's inject, I forgot to mention our current user service. I'm sorry about that. Let's go and see that now we have a current user service that returns the ID from the claims of a user. Now it only has that one property. Let's go and inject that in our behavior. So I current user service, and let's initialize that from the constructor. Okay. Now we need to see if our request has any authorized attributes and then deal with them. So let's go and say authorized attributes equals with request.getType, so that we can have the type of the request, and then in that type we need to take the custom attributes, and they need to be of type authorized attribute. And also let's say that we need the role to be greater than equal greater than 0, which is the default value of an enum. Alright, now if it doesn't have any authorized attribute, so if not authorized attributes dot any, we can continue processing our request, so return await next. Okay, now in that point, if it has an authorized attribute, we could make a method in our identity service that takes the ID of the user. We will have that ID from the current user service. we pass that to our new method in identity service, and in there we can find the user from the table and implement the logic of the authorization. That's the more common way dealing with this, but and it's great for a more complex policy that we need some other stuff from the user. But because we are dealing with a simple role-based authorization, we're gonna take another approach just to experiment with it. We will go to our current user service. Okay, and we're going to add a new property, and we will return an I number of strings, and every string will be a role of that signed in user. So public enumerable of string, we will call that roles http context accessor dot http context dot user dot claims, where the type is claim types role, because that's because that's the type we used when we created our token for the roles. So claim type dot role, and we need to get the value of that role, since claim has a type and a value. So x.value, and if that's null, let's return an empty enumerable of string. So enumerable dot empty of type string. Now let's move that to our current user service as well. Okay, and now we can access that from the current user service. So let's take the user roles. Var user roles equals with current user service dot roles. Okay, now we will iterate on the roles. In our example that we are using a hierarchy of roles, maybe it's a little bit redundant, but it doesn't hurt. So let's say for each role in our authorized attributes, in authorized attributes dot select role, and that's yelling because of possible multiple enumeration. So let's add that in here. Now in here we need to check if that role is if that the user roles contain that role that we need to have to process our request, to continue processing our request. So let's create a private method in here that will do that job. So that is authorized, and in here we have the required role, as well the list of the user roles. Okay, and now we need that user role to contain the required role to string, or any of the user roles is actually bigger than the required role. So user roles dot any, and we need to pass that to an enum, to the enroll enum. Okay, and we need to be bigger. Actually, if we go to our enum role, the admin, which is in the big in the hierarchy, is the one with a smaller number, so we need to say that that's smaller than the required role, and we can return, or we can just say here smaller or equal and remove that contains, but it's okay for now. So let's go back to our loop. So if is authorized, and let's pass the current role and the user roles to list. Then we need to continue processing our request. So it again complains for possible multiple enumeration, so let's move that to list in there, and we are good to go. And now if our user is not authorized, we will throw an exception. Okay, so in our application project, let's call a new folder called exceptions, and in here we will have a forbidden exception. Okay, that needs to inherit from the exception class, and we need the constructor as well. Okay, it will not have any message, it will be just a forbidden exception, and by the type we will handle that later. Okay, so now let's go and throw that forbidden exception. Okay, now we need to register that authorization behavior. So let's go to our dependency injection class, and in here let's register our behavior. So services add transient, we need to register a type of iPipeline behavior, and that type, it will be our authorization behavior. Okay, and we are good to go. Now what will happen if we have a forbidden exception? In the API project we have a custom exception middleware. It has a handle exception async method. For now we have only the default case that in any exception we return an internal server error HTTP code with a message something went wrong, and we just log that exception. Now we need to add a case, and that case will be if it's a forbidden exception. So case forbidden exception, the code will be http status code dot forbidden, and let's say that the message will be just an empty string, and now we can have the same HTTP response that a forbidden request has out of the box with ASP identity. Okay, now the only thing it's left to do is to decorate our queries. So the supervisor query will be decorated with that authorize attribute, and the role will be supervisor. Let's copy that and do the same for the manager. Let's add the namespaces, and finally the same for the admin. Let's add the namespaces. Okay, and now let's debug our program to see how our code works. I'll open Postman, and let's make that a little bigger. Okay, as you can see, I have already created a sign-in request and I'm signing in as a manager. So if I send that, I'll get back my JWT. I'll put that in the header of each request. Okay, and now if I go to get the manager message, since I am a manager, I get back hello manager. If I go to the supervisor message, I will get that because my role as a manager is higher than the supervisor role. Okay, hello supervisor. But if we go to the admin endpoint and try to get the message for the admin, I'll get an internal server error. Yeah, I mistyped here. That's not a format exception, it's a forbidden exception. Now let's debug that again. Let's wait some seconds. And now let's go to our admin. We will hit the send and we get a status 403 forbidden, as we will have if we had the authorization in the API level as previously. So let's go and put a breakpoint as always to see exactly how that works. Okay, let's hit send and now it hit our breakpoint. Now as you can see, the type of the request is an admin query there. Okay, the authorized attributes, they have count of 1 and they have the admin role. So our roles, as you can see, is a manager role. So it will go to the authorized the helper method. That will return false, so it will go and throw that forbidden exception. And if we go to our custom exception middleware, we will catch the exception in here and then we will handle that exception in there. So let's hit continue, and as you can see, our exception is an forbidden exception, so we will return that HTTP status code forbidden. Okay, that's all I had for this video. Thank you for watching and have a nice one.